Okay, today we're going to do arc length of vector valued functions, and it's pretty straightforward. It's just a simple integral. Okay, now depending upon the function, the integral might be easier or harder, but the idea of arc length for a vector valued function is simply just calculating an integral. Okay, so let me write this down. If we have the vector valued function r of t, okay, the arc length along the path of r from t equals a to t equals b is, and here's the formula. It's the integral of the magnitude of r prime of t integrated with respect to t from a to b, and that's what it is. So let's do an example. Okay, down there on the left you see a picture of something called a cycloid. We've seen those before when we were doing parametric equations at the beginning of the course. Okay, that particular cycloid has parametric equations. X of t equals cosine of t plus t. Y of t equals 1 minus sine of t. Okay, what I'm going to do is I'm going to write that as a vector valued function instead of parametric equations. So I'm going to write r of t equals the vector cosine of t plus t, comma 1 minus sine t. Because we're doing vector valued functions now, so I want to write that cycloid as the curve described by this vector valued function. Okay, I want to remind you, because I know this is how they do it on Newton, that we can also write that like this: cosine of t plus t I plus 1 minus sine t j. Okay, that means the same thing. This up here is written in component form. It's got an x component and a y component, or some people call those an I component and a j component. And this right here is written in the form as a combination of the standard unit vectors I and j. Whichever way you prefer to write is fine. I prefer the first one. Okay, here's what I want to do. Let me point something out to you here first of all. Let's just look at one hump of the cycloid, this first full hump from there to there. Okay, that hump starts when t is pi over 2, and it ends when t is 5 pi over 2. Okay, and what I want to do with you is I want to calculate, if you walked along that hump, how far would you travel? That's what I want to calculate with you. Okay, so the question will be this. Whoops. What is the arc length along R from t equals pi over 2 to t equals 5 pi over 2. Okay, here's how you do the problem right here. So we're going to integrate the magnitude of r prime. Okay, integrate the magnitude of r prime. So let's write down r prime and let's find its magnitude. Okay, let's do that. So r prime of t equals the vector negative sine of t plus 1, comma, negative cosine t. Okay, that's r prime. Whoops, I forgot the vector symbol. Okay, all right, let's find the magnitude of that. The magnitude of r prime will be the square root of negative sine of t plus 1 squared plus negative cosine of t squared. Let's just simplify that. So that's going to be the square root of, we'll have sine squared t minus 2 sine of t plus 1 plus cosine squared t. Now the sine squared plus the cosine squared gives us 1. Added to the one that's already there, we're going to end up with negative 2 sine of t plus 2. Okay? And we want to integrate that. We integrate the magnitude of r prime. With respect to t from pi over 2 to 5 pi over 2. That's going to be the arc length that we're looking for. Okay. Now, how are we going to calculate that integral? Okay, well, first we're going to do a little bit of work with some trig identities to make it an easier integral. Okay, so let's go off on the side here. And let me just show you this simplification. That'll make the problem easier. I'm going to write negative sine of t plus 1. Okay. Actually, let me rewrite that though as 1 minus sine of t. Okay. 1 is the sine of pi over 2, so let's write that as the difference sine of pi over 2 minus sine of t. Okay, using the angle difference identities, that is the same thing as 2 cosine of pi over 4 minus 1/2 t times sine of pi over 4 minus 1/2 t. That's just using the angle difference identity. Okay, and now one other trick I'm going to do is using what's called the cofunction identity. That cosine right there is the same thing as sine. By the way, I made a small mistake. That minus there in the cosine was supposed to be a plus. Okay, there we go. Fixed that. Okay, that cosine of pi over 4 plus 1/2 t is the same thing as sine of pi over 4 minus 1/2 t. That's using what's called the cofunction identity. Okay? See those two signs right there are the same? So I can write that as 2 times sine of pi over 4 minus 1/2 t squared. Okay, that's going to make our problem that we're doing in blue easier, because now I can write this as the integral of the square root of, so do you notice that this right here is just 2 times this? So that means it equals 2 times this. So I'm going to write 4 sine squared of pi over 4 minus 1/2 t. Okay. Now, of course, that 4 can come out. Square root of 4 is 2. And I can even take that and put it out here instead. Okay, now I have the square root of sine squared. What's that equal? Think about it. And with all due respects, I will tell you that I think you're probably going to get it wrong. No offense, but everybody does. What is the square root of sine squared? Most people say it's sine. The square root of sine squared is sine. That's not true. It's the absolute value of that. That's the correct answer. Okay. So there we go. You've all taken Calc 2. You should be able to work your way through a difficult integral. Okay, and this one isn't really all that bad, except it's just that we had to use those trig identities at the beginning, but nothing since then has been very difficult. Okay, now I'm going to suggest that we do a u substitution here. Okay, how about if we write u equals pi over 4 minus 1/2 t. That means that du equals negative 1/2 t. Sorry, that's not true. Negative 1/2 dt. Which means that dt equals negative 2 du. Okay, so this part right here, let me do that in another color. Let's circle that in. Let's use this pink here. This part right here gets replaced with u. This part right here gets replaced with negative 2 du. But don't forget, what do these get replaced with? We got to do that as well. Okay, so u equals, I'm looking at this right here, u equals pi over 4 minus half of t. So that means that when t equals pi over 2, that means that u will equal pi over 4 minus half of pi over 2, which equals 0. So that's going to get replaced with a 0. When t equals 5 pi over 2, that means that u will equal pi over 4 minus half of 5 pi over 2. And that equals negative pi. So that 5 pi over 2 gets replaced with negative pi. Okay? I'm going to delete that scratch work in a second. So if you want to write it all down, then pause the video and write it down. Okay, so what we now have is 2 times the integral, where we're now integrating from 0 to negative pi. We're integrating the absolute value of sine of u. And then at the end we have times negative 2 du. Okay, I'm going to take that negative 2 and move it out here in front. And when it hits the 2 that's already there, we end up with negative 4 times this integral. Okay, this should now be very, very easy. Okay, well, there is one more spot that I think will trip some of you up, so let's be careful here. One more thing here. Let's get rid of that absolute value thing. Okay, is this true? Let me ask you a question. I'm going to write down 2 things. Which one's correct? Should it look like that? Or should it look like this? That, by the way, pi up there should have a negative sign. Which of those 2 is correct? Well, let's think about it. When you look at the unit circle, we're going from 0 to negative pi. So that means we're going here. From 0 to negative pi. Is the sign of those angles positive or negative? The sign is negative, right? So is the absolute value of sine going to be sine? No, because absolute values are never negative. If the sign is negative in that area, then the absolute value of sine has to be the opposite of sine in order for the absolute value to be positive. If sine is negative, then negative sine is positive. Okay? So, let's slide that guy over in his rightful place. Okay. Something else you might want to do, it's up to you, but you can take that negative sign out front, and then you can just write positive 4 times the integral of sine. What's the integral of sine? It's negative cosine, right? Oh, now that I think about that, I would rather have left that negative sign inside. So I'm going to erase this because the integral of negative sine is cosine. So we have negative 4 times cosine of u. From 0 to negative pi So that's -4 cosine of negative pi minus cosine of 0. So that's -4 times -1 minus 1, which is -4 times -2, which is our answer, 8. It's a long problem, but it wasn't difficult. Let's go back up here and let's look at our original question here. And the answer is that if you walked along that one hump of the cycloid, you would walk 8 units of distance. And that's how you do arc length.